Okay, so I will now talk about graphs of polynomials. So you find this on pages 21 to 23 of your Origo book. Okay, so if we have this polynomial function, which is given by this polynomial expression, x cubed minus 3x, then this is the same example that is on your book on page 21, and I've sketched it here. Then the graph looks like this. So we can say that this is a graph y equals p of x. Okay, and we could also choose some x values, and we could make a table. So the algebraic form, the graphical form, and the table form, these are really the three main representations for a function. Okay, so there's two keywords that we need are zeros, in Swedish nollställe, and roots, in Swedish rötter. Okay, so the zeros of p of x, the zeros of the function p of x, and the roots of the equation p of x equals 0 are equal. However, we have to be careful with these words that when we're talking about the function, we should always use the word 0. And when we're talking about this equation, we should always use the word roots. Okay? And here I've also made a statement that the equation of the line of the x-axis is y is 0. Okay, so along the x-axis, then y is 0. So we can think if we have a graph y equals p of x, okay, and y equals 0, then at those intersection points where they meet, then at those points, then p of x is equal to 0. Okay, so those x values, those are going to be the roots of that equation. Okay, and those x values are the zeros of p of the function p of x. Okay. Now on page 21 in the box on the box, then there's also some key information that is useful to know, and that is that when we have a polynomial function of degree n, so in Swedish grad n, then it means that there's a maximum of n. There's a maximum of n zeros. Okay, and it's also the case that there's a maximum of n roots, or real roots, we can say. So that's one thing I should say when we're talking about this. We're talking about real roots. Okay. So on page 22, then they show some examples with graphing. So I have some comments here. So when you're graphing using your graph display calculator, then having the right window settings is key. Okay, so when we have now graphs of polynomial functions, y equals p of x, then they can have more wiggly shapes. Okay, so we see that when we have degree 3, then there's the maximum number of turning points is always 1 less than the degree. So if the degree is 3, there could be 2 turning points. If the degree is 4, then there's a maximum of 3 turning points, and so on. So we can get some wiggly shapes, so we need to have a good view. So you can, to find the zeros, you can press sec and calculate and choose 0. Then you do the left bound, right bound, and guess to get the zeros. And to get intersections, then it's a similar thing, sec and calc, intersect, first curve, second curve. And please remember, do not find values by moving the cursor. You have to find these you have to find if you're going to find accurate values, it has to be done using really using this calculate menu. Okay, if you have one of these TI-84 calculators, you can get zeros using the polynomial app as well. Okay, so that was a little overview of pages 21 to 23, and it's well explained in the book, so check that out too. Thanks for listening.